In this multiplier analysis, we have an ARDL11 model. And here, that's our regression output. That's the result. We have the coefficients. And we calculated the multipliers manually by using those formula. You may notice that the first one is just the coefficient of GT. That's the immediate impact from GT to the dependent variable du. And of course, we call it distributed lag model because the effect of GT will be distributed among several period of times. It's not one-off. So this is just initial impact. And we have some other impact smaller, but it comes from the later period. For example, one period later, beta 1 is calculated by using this formula. Okay, so delta 1 hat is just this one. That's the 0.992, the coefficient of GT minus 1. And we have the coefficients corresponding to GT and DUT minus 1 as well. Then we can calculate, okay, in the second period, one period later, beta 1 hat or the impact is minus 0.1636. Then starting from the second period, lag 2, you may notice the calculation is kind of iterative. It's just the previous beta estimation times theta 1 hat. Okay, and this can easily be realized in Stata. So now let's go to Stata. Let's first estimate the ARDL11 model. So that's our ARDL11 model, and you can see the coefficients as shown on my PowerPoint slide. Then you can use these command lines to calculate B0, B1, B2, and so on accordingly. So that's just the formula that we had. So this one, that's underscore B, G, that's the coefficient of G. And we also have the coefficients from other variables as indicated here. So if you submit these four command lines, you may notice B0, B1, B2 are calculated as exactly as the one shown on my PowerPoint slide. You can compare those values, they are the same. So this is to calculate them one at a time. Starting from B3, you can use the same formula, okay? You can also make use of the variable generation function because starting from B2 is iterative, it's the same formula. So what we can do is use this. We generate a variable, it's called MULT, and we set the value of its first observation to be B0. So this is the B0. Then for B2, we use the same formula. To B1, the second observation, that's B1. We change its value accordingly. That's the same formula as we used before. And starting from the third observation is exactly the same formula. It's just theta 1 hat plus the previous estimation. Okay, so we use this lagged operator to obtain the previous estimation. So then once we finish the calculation, we can list MULT, the first 8 lags. The reason that I stop 8 is because I checked the value up to lag 8. The effect is very small. It's virtually 0. So it's minus 0.3. It's close to 0. So I stop there. These are the initial impact and intertrim impact from G to DU. And then you can calculate the total effect as well. We can also plot the chart. So we can visually demonstrate the effect. We generate a variable that's essentially it's just the number, the observation number. So underscore n-1 gives us the number of the numbers of the observation, and it's only from 1 to 8. And line is the command to generate the line chart of MULT. That's the multipliers that we calculated, and we use lag on the horizontal axis. So once you submit this to line, you are going to see this window open in front of you, this one. So we plot MULT, the value is negative. So even it looks like it's increasing trend over there, it's because the value is 0 from below 0 line. So the impact is getting smaller and smaller. And we use lag from 0 all the way to 8 as the horizontal line to label the changes. So this is how to conduct multiplier analysis, or how to obtain those B's, those multipliers based on the ARDL model.